Hello, grade 10s. In today's lesson, we're going to be looking at trigonometry and we are doing practice problems. So without any further ado, let's just get right down to the lesson. Ra. So here we are given question 5. It says in the diagram below, P with the coordinates x is to y is a point in the third quadrant. So as we can see there, we have the first quadrant. This is the second quadrant. And then the third quadrant, this is where we have our drawing there. And this one, of course, is the fourth quadrant. Now we are given that ROP, this reflex angle here, is equal to beta, and we are given 7 cos beta plus 15 is equals to 0, right? So with this, we can see that we do not have any sides that is given here, besides that we have this xy being the coordinate. Now remember, we said the two concepts that will work here is your r squared is equals to x squared plus y squared, and also we need to use SOHCAHTOA, right? So these are the two concepts that work here. But then in order for us to use this concept, we have to make sure that our diagram is a right angle triangle, right? So we just go ahead and join this to a vertical line so that we have a right angle triangle. Now the next thing we want to do is to work with the 17 cos beta plus 15 so that we make our cos beta the subject of the formula, right? So remember, we should have this in the form of SOHCAHTOA, whereby we'll have this in a form of a fraction, having our adjacent and our hypotenuse side. So we want to resolve this so that our cos beta is the subject of the formula. Now let's remind ourselves of what SOHCAHTOA is. So here we have our trig ratios. Sine, remember, is opposite over hypotenuse, and then cos is adjacent over hypotenuse, and tan opposite over adjacent. So as indicated here in this right angle triangle, right? Now let's get to solving the question. So we are given 17 cos beta plus 15 is equals to 0. So we are supposed to calculate the sides x, y, and r, because we do not have the values for that. So now let's make cos beta the subject of the formula. So first thing is we want to transpose this positive 15 to the other side, so it becomes negative 15. Then at this point we divide both sides by 17. So now we can see that cos beta is the subject of the formula. So we have negative 15 over 17. Now knowing that our cos is cos beta, that is adjacent over hypotenuse. So remember, adjacent over hypotenuse can also be written as x over r. So we know the adjacent side will be the x and the hypotenuse side is that r, right? So now having to come back here, let's see now, for x here, what do we have? We have that negative 15, and then for r here, we have 17. Now to calculate the missing side without any angles given, we must now use Pythagoras theorem, right? So now to calculate that one, we have r squared is equals to x squared plus y squared. Remember, we do have the value for r now, that's 17, and then square that, and then we do also have the value for x, so that's negative 15, and then square plus y square, right? Then at this point, what do you want to do? You calculate 17 square, then minus negative 15 square is equals to y squared. So if you punch all this in your calculator, that should give you 64. So we have 64 y squared. Then remember, we are looking for y, so we have to square root both sides, and then we have y coming off as plus or minus 8. Now, according to our Cartesian plane here, we can see that our Cartesian plane for the y values that are below the x-axis. So we know if our graph is below the x-axis, the y has to be a negative value. So that means y there, y is equals to negative 8, right? So we have y is equals to negative 8. Now, we have 5.1.2. It says, without using a calculator, determine the value of a, which is sine beta, right? Now that we have all the values there, so let's do this. Now that we have all the values, let's indicate the values that we have. So we have our negative 15 here, and then this is 17. And for this side, we got negative 8. So now that we have all the values, we can calculate sine beta here. Remember, sine is opposite over hypotenuse. So if we have our angle here, what is our opposite side? That's negative 8. And then what is our hypotenuse side? That's 17. So for that one, we have sine beta is equals to negative 8 over 17. So that becomes your solution. Now let's go to B. B says cos squared 30 degrees times tan beta. So we must calculate the value of cos squared 30 degrees tan beta. So, but remember, they said without the use of a calculator. So that means we must find this cos 30 using the right angle triangle, right? For special angles. Now let's have a look at that right angle triangle for special angles. So this is it. This is the one that we have. So looking for cos 30, that means we're gonna come here. We know cos is adjacent over hypotenuse. So now coming to this one, we'll say what is adjacent to this 30-degree angle? We can see that our adjacent side is root 3. And what is our hypotenuse? That's 2. So meaning our cos 30 degrees is equals to root 3 over 2. As we can see here, this is cos 30, and then it's giving us root 3 over 2. So how are we going to write that one? Remember, we are given a cos squared 30 multiplied by tan beta. But we have already seen that our cos 30 is root 3 over 2. Now, do not forget this is squared, so we have to include that square there. And then what is our tan beta? So we go back to the diagram. From the diagram here, we can see that our tan beta here is negative 8 over negative 15. So negative 8 over negative 15. So we have negative 8 over negative 15. Now having to deal with this one, we know root 3 to the exponent of 2, that will give us 3, and then 2 to the exponent of 2, that is 4, and then we have this, so that's 8 over 15, right? Then obviously calculating this one, we have 3 times 8, which gives us 24, and then 4 times 15, that gives us 60. Now, looking for a number that can go to 24 and 60 and leave no remainder, we have 12. So we can divide here by 12 over 12. Then 12 goes how many times to 24? It goes 2 times. But 12 goes how many times into 60? It goes 5 times. So our solution is 2 over 5. Okay, so 5.1.3 says calculate the size of ROP correct to 2 decimal places. So now before we calculate that, let's fill in all the information that we have. We have negative 8 here. we have negative 15, and then we have our hypotenuse as 17. So we want to calculate the size of ROP, which we can see here is this reflex angle. But remember, here, what do we have? If we apply 180 plus beta, that means here we have beta, right? Then this falls in the third quadrant, right? So we have 180 degrees plus beta, so that's our beta there. Then having to calculate this, we can use any trig ratio here to calculate the size of beta here. So remember, we have SOHCAHTOA, and then since we have all the information, that means we can use any of the trig ratios here to calculate the angle. But then since we have just recently calculated for tan beta, we might just as well use that, right? So let's calculate beta using the trig ratio tan. So we have tan beta is equals to, we know that's opposite over adjacent, right? Then our opposite side is -8 and our adjacent side is -15 from the diagram, right? Then that means we have tan beta here is equals to 8 over 15. So negative divided by negative becomes a positive. Now to calculate for the angle, we need to leave it on the left hand side, and then when we transpose this one, it jumps to the other side, it becomes inverse, right? So that's tan inverse, and then we have in brackets 8 over 15 and then close bracket. So when you press shift tan in your calculator, you can see that it becomes this, right? Then that's beta tan inverse tan 8 over 15. Press that in your calculator, it becomes 28.07 degrees, right? But then remember, we are not looking for beta, we are looking for ROP, right? Which is the reflex angle 180 degrees plus beta, right? So to calculate for ROP, what do we have here? We have this 28.07 added to 180 degrees, because 180 degrees, this is a straight line, right? And the angle that forms as a result of a straight line is 180 degrees. So hence we have that 180 degrees plus beta. So to calculate ROP, we have 180 degrees plus 28.07. Then our solution becomes that should give you 208.07 degrees, right? So that's how we have it correct. Now for 5.2, it says in each of the following equations, solve for x where your x should be an element of 0 degrees up until 90 degrees. So your angles should be within the first quadrant. Then give your answers correct to 2 decimal places. So once your question says correct to 2 decimal places, then you know you can use your calculator, right? Because remember, you cannot find at least to 2 decimal places without the use of your calculator. So all these questions indicate that you are now allowed to use your calculator. Then let's calculate for 5.2.1. We are given there tan x is equals to 2.22. Now to calculate for x, we leave x here on the left hand side and then transpose the tan, it becomes inverse tan, and then we have 2.22, right? Then punching that in your calculator, it should give you something like 65.75 degrees rounded off to 2 decimal places. 5.2.2, we are given sec, right? Then where we know that sec is an inverse of what? Of cos. So if we go back to this, we know that if we have cos sec, let's say cos sec beta, counting here we have 1, 2, 3, so this becomes an inverse of sine. right? So this would be an inverse of sine beta. And then if we have sec, so that's secant, and then secant beta, we count 1, 2, 3, and then we see that that's a C there. So that means this is an inverse of cos. And then if we count the last one that we have is cotangent, and then cotangent beta, we count 1, 2, 3, that's a tan. So we know that's an inverse of tan beta, right? So that's it for this. So calculating for sec, how are we going to approach this question? We have sec x plus 10 degrees is equals to 5.759. Now we know sec is an inverse of cos, right? Sec is an inverse of cos because the dead letter here is C. So we have cos, just replace the sec by cos, and then we have x plus 10 degrees. But remember, we have included an inverse here. So we need to write this number in a form of an inverse. So writing that in a form of an inverse, we just say 1 over that number, then 5.759. So this indicates that we now have an inverse function. Then x plus 10 degrees is equals to cos, and then have that inverse, and then 5.759. Punching that in your calculator, you should get 80 degrees, and then we have x is equals to 80 degrees minus 10 degrees, and then x is equals to 70 degrees. So that's your solution. Now for the last one, we have 5.2.3, and then we are given sine x over 0.2 minus 2 is equals to 1.24. Let's tackle that one. So we have sine x over 0.2 minus 2 is equals to 1.24. Remember, with this is what you want is you want to isolate the trig ratio in the left hand side. So you want this trig ratio to be left alone here. So the first thing that you will do here is you can see that this -2 is a constant, so you can just bring it over to the other side. You have 1.24 plus 2. Then having that, you have sine x over 0.2 is equals to 1.24 plus 2. That should give us 3.24, right? Then 3.24, if you cross multiply here, remember 3.24 can also be written as 3.24 over 1. So if you cross multiply here, you have sine x multiplied by 1 is sine x. And then you have 0.2 multiplied by 3.24. That gives you 0.648, meant to say 0.648. And then now calculating for x, we say x is equals to sine, arc sine, and then we put that 0.648. Now punching that in your calculator, your x should be 40.39 degrees. And that's how you have your solutions. Awesome, awesome.